Introduction. Arun, do not put that nail in the plug. You will get an electric shock. Why, teacher? It is a rusted nail and of no use to us. Though the nail is rusted, it is a metal, that is, a good conductor of electricity. If you put that in the plug, it will give you a shock. Oh, you saved me! Children, in this lesson we will learn about metals and non-metals, the chemical and physical properties of metals, the extracting of metals, and the corrosion of metals. Objectives. At the end of this lesson, you'll be able to describe the physical and chemical properties of metals and non-metals, identify how metals and non-metals react, explain the occurrence of metals, describe corrosion. Physical properties. Metals. You come across a lot of metals and non-metals in your day-to-day life. For example, the hammer that you use to fix nails is a metal. The nail made of iron is also a metal. Let us look at the physical properties of metals. The physical properties of metals are: physical state. Metals are solid at room temperature. For example, iron, aluminium. Only mercury is liquid metal. Good conductors of heat and electricity. Metals are good conductors of electricity as they have free electrons. For example, silver and copper are the best conductors of heat and electricity, whereas lead is the poorest conductor of heat. Malleable. Metals can withstand hammering and be made into thin sheets known as foils. For example, iron is heated and then hammered into different forms, foils, shapes, etc. Ductile. Metals can be drawn into wires. For example, 100 gm of silver can be drawn into a thin wire of about 200 meters long. Luster. Metals reflect light from their shiny surface. They can also be polished. For example, gold, silver, and copper are metals with a shiny surface and can be polished. Physical properties. Non-metals. Let us now look at the physical properties of non-metals. Physical state. Non-metals exist in as solid, liquid, or gaseous in state at room temperature. Gas, oxygen, chlorine, fluorine. Liquid, bromine, and solid, carbon. Non-malleable and non-ductile. Non-metals are brittle and cannot be rolled into wires or beaten into sheets. Poor conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. Graphite, carbon, is an exception as it is a good conductor of electricity and is used in making electrodes. Luster. Non-metals have no metallic luster and do not reflect light. Did you know? Metals are solid at room temperature. The only exception is mercury, which is liquid. Mercury, the liquid metal, conducts heat and electricity as well. It is very dense. Mercury is very poisonous. Non-metals are poor conductors of electricity. However, graphite, which is a form of carbon, is a good conductor of electricity. Chemical properties of metals. Let us look at some chemical properties of metals. These properties include reactions of metals with other elements, that is, air, water, acids, and other metal salts. With air. When metals come in contact with air, they form metals oxides. There are some metals that show both basic and acidic properties. Such metals are called amphoteric oxides. With water. When metals come in contact with water, they form metal hydroxides and hydrogen. Metal make the water become a metal hydroxide solution. With acids. Metals react with dilute acids to form salts and hydrogen. This reactivity varies from metal to metal. However, when metals react with nitric acid, hydrogen gas is not formed as this acid is a strong oxidizing agent. With solutions of other metal salts. A more reactive metal displaces a less reactive metal from its salt solution. To put in simple words, If metal A displaces metal B from its solution, metal A is more reactive than B. However, not all metals are reactive. In this reaction, the copper contained in the copper sulfate is replaced by zinc. The reactivity series. Metals being arranged in the decreasing order of their reactivity is called a reactivity series. It is used to summarize information about the reactions of metals with air, acids, and water. How do metals and nonmetals react? Metal atoms have 1 to 3 electrons in the outermost shell, whereas nonmetals atoms have 4 to 8 electrons in the outermost shell. Exception. 2 exceptions to this rule: hydrogen and helium. Metals that donate electrons gain positive charge equal to the number of electrons donated, and nonmetals gain electrons and negative charge equal to the number of electrons accepted. When a metal atom donates 1, 2, or 3 electrons from its valence shell to another nonmetal atom that has the ability to accept these electrons, it is known as electrovalency. As a result of this, both these atoms form the structure of an inert gas. The transfer of electrons from the atom of an element to the atom of another is called an ionic compound. Properties of ionic compounds. Let us look at some ionic compound properties. Physical nature. Ionic compounds are hard solids as the force of attraction between the positive and negative ions is very strong. These compounds are brittle and break when pressure is applied. Melting and boiling points. Ionic compounds have high melting and boiling points because of a considerable amount of energy that is required to break the strong inter-ionic attraction. Solubility. Ionic compounds are soluble in water and insoluble in solvents such as kerosene, petrol, and so on. Conduction of electricity. Ionic compounds, when in solid state, do not conduct electricity as the movement of ions is not possible because of the rigid structure. But when ionic compounds are in a molten state, it is possible to conduct electricity as the electrostatic forces of attraction between the oppositely charged ions are overcome due to the heat. This leads to ions to move freely and conduct electricity. Did you know? Positive to positive and negative to negative ionic bonds do not occur, just as the similar poles of a magnet repel. Occurrence of metals. Extraction of metals and ores. Earth is the major source of metals. However, seawater also contains some soluble salts. Minerals are the elements or compounds which occur naturally in the Earth's crust. Sometimes minerals contain a very high percentage of a metal. This metal can be extracted from it. Such minerals are called ores. Ores are impure metals that contain a large amount of sand and rocky material. These impurities in the ore are called gangue. These impurities have to be removed from the ore before the metal is extracted. Once the impurities are removed, the ore is in a concentrated form. This concentration of the ore is also known as enrichment of ore. Extracting metals. After the metals are separate from their ores, they are classified based on their reactivity. The following are the various categories of metals grouped as per their reactivity. Extracting metals low in the activity series. Metals that low in the activity series are very unreactive. The oxides of these metals are reduced to metals by heating alone. Extracting metals in the middle of the activity series. The metals in the middle of the activity series are moderately reactive. These metals are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide. Therefore, first these metals need to be converted to their oxides. The process used to convert sulfide ores by heating strongly in the presence of excess air is known as roasting. The process used to convert carbonate ores by heating strongly in limited air is known as calcination. Extracting metals towards the top of the activity series. The metals that are high up in the reactivity series are very reactive and cannot be obtained from their compounds by heating with carbon, as these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. Refining of metals. The metals produced by reduction processes are not pure. They still contain impurities, which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Many metals are refined electrolytically. The impure metal is made the anode, and a thin strip of pure metal is made of cathode. A solution of the metal salt is used as an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode. These are known as anode mud. Did you know? Silver, gold, and platinum atoms are not easily oxidized. So, silver, gold, and platinum simply fall from the anode to the bottom of the tank, where they can be scrapped up after the electrolytic refining process is complete. Corrosion. Metals that are chemically active get corroded in the presence of a moist atmosphere. Corrosion is an oxidation reaction with atmospheric oxygen in the presence of water on the surface of a metal. For example, iron and aluminium corrode. However, non-reactive metals like gold, platinum, mercury do not corrode. There are 3 ways to prevent corrosion. Sacrificial protection, where the more reactive protecting metal is oxidized away, leaving the protected metal intact. Alloying, where metals are mixed with other metals to make non-rusting alloys. Galvanizing, where a metal is covered in thin zinc layer. This layer is produced by electrolytic deposition. Summary. Let us summarize what we have learned. Metals are good conductors of electricity, whereas non-metals are poor conductors of electricity. Metals react with air, water, and acids. Metals being arranged in the decreasing order of their reactivity is called a reactivity series. The transfer of electron from the atom of an element to the atom of another is called an ionic compound. Metals are extracted from ores. The most widely used method for refining impure metals is called electrolytic refining.